Welcome to this week's Swarf and Chips. There's lots to look forward to today. So firstly, we take a look at the new Mazak CV5-500 fifth axis machine that was recently exhibited at Autosport. Paul goes skiving at Halifax Rack and Screw. Mark talks metrology with Alicona about their optical solution. And finally, Colin visits the ABB facility to take a closer look at the automated applications that are possible. Welcome to this week's Swarf and Chips. Right, how are you guys, gents, before we start?
Yeah, really good. Have you not been out with the Two Ronnies?
Yeah, I have actually. I have. Should we have a little look?
Excuse me.
Yeah.
You got 4 candles?
Oh, I've got 4 candles.
Ah, perfect. Yeah. All right. What about you got any O's as well?
O's? O's?
No, not garden O's. O's. O's.
O's. Ah, O's.
Lovely. There we go.
Yeah.
You missed a bit. What about the peas? The tins of peas?
Pumps?
Pumps, yeah.
Well, we were actually out on the road and we're so privileged, aren't we, to be able to go around, see so many companies. And we were at the Air Supply Sheffield and the company was quite old school in there. So they said, why don't you do the Two Ronnies sketch?
And you'd never seen the real one?
I can't believe
never
that.
seen it.
I can't believe that.
Yours was better though.
Yeah, well, obviously. So where are the overalls? Let's go in. Right, okay, let's start with a UK manufactured machine that's really made its mark on the world.
So I'm here with Tim from Mazak at Autosport International. And Tim, we're looking at the CV5-500, very popular machine at the show.
Oh, very popular machine. I mean, it's good to have lots of people viewing our new products, and it's good to see that we're not a company that people are scared to come and look at, which is good.
Yeah, so what are the highlights on the machine?
Well, the highlights are it's basically aimed for an entry-level sort of 5-axis compact machine for good small footprint size, but still made with good quality components that we have across the whole of our Mazak range.
So there's no compromise on the quality you expect from a company like Mazak?
Oh, no, not at all, no. It's got all the same sort of high-level Mitsubishi stuff inside. The beauty of it is it's been designed to keep it as a cheap manufacturable item, but still with the proper Mazak quality that we like to see and offer.
So you say commodity, but maybe only the price is commodity, not the machine?
Yes, exactly, yeah. I mean, we've priced it well at the market, and the interest has been good because of that, I think.
Yeah. UK built, UK manufactured as well?
Yeah, and designed. Everything has all been used, resourced from Worcester, and manufactured, machined, assembled, designed, and tested all down at our Worcester plant, which is our European HQ.
And that's a tried and tested solution, isn't it? You've got machines like the VTC, other models as well, have been designed and manufactured in Worcester. That's
correct, yeah, and hopefully, I mean, that was 10 years ago when that one was released, so this will be another 10-year legacy that we'll leave coming out of Worcester, which will be good.
And we're here at an Autosport show, but it's not just for Autosport, is it? Anyone doing complex 5-axis machine parts?
Yes, exactly, yeah. I mean, any sort of products can be made on this type of machine. Anything where you want to minimise your setup time, get things manufactured all in one setup, which then increases your reliability on accuracy tolerances, and then hopefully keeps people's lead times down, which is unfortunately the magic word nowadays. Everybody wants the stuff yesterday.
Absolutely, thanks Tim. So there we have it, the CV5-500 from Mazak.
Right, impressive. Paul, my question really is, with this machine, there's a lot of competition in the industry. People are going to want to invest in the Mazak technology, and they're bringing in something that is maybe more entry level. Am I correct?
There's a podcast actually on our channels which we did with Alan Mucklow and Lawrence McCann and the production director from the factory at Mazak, talking a lot about the journey of the development of a machine. Now, quite interestingly, this was born out of their customers saying that we want a high quality, quick, very competitively priced 5-axis machine. And that's what they've delivered here. Now, what is really interesting, and this is on the podcast as well, is that the actual design of this machine, or the development of this machine, started at MAC 2018. So the idea was born at MAC 2018. And now with MAC 2020 just around the corner, less than 2 years, they have designed, developed, and now sold these machines. Now that just shows you the ability of the business to adjust and adapt according to customers' needs. They also mentioned in the podcast, and it is definitely worth a listen, about how they identify business segments, and they look to say, okay, the energy industry is going to change in the next 5 years, so we need to develop a machine which is perfect for components for that.
Wow, okay.
So they've got a whole team of people, looking at which areas of industry are going to change, and then they're going to develop products to suit those.
A fantastic machine. I mean, not much more I can say than that, really, Paul.
We're all
I think
like
you've
this.
covered it perfectly. I think it's, so well designed, from the ground up, ergonomically, the footprint's really small, but with a large working envelope, the Y-axis construction going into the back of the machine, bridge construction across the top. What more can I say, really? I think you've touched upon it perfectly.
Yeah,
Great
a lot
machine.
of people do like the Mazak name, and so they want something to fit the name and everything that's behind the name.
It's a trusted source for a machine tool that's made here in the UK. You can go and see it being made.
And before we go on to the next bit, I just want to mention the podcast. So maybe if you can...
the podcast. Yeah, I mean, every week there's a podcast, sometimes more than one. The Mazak one was fantastic, but there's plenty that you've done as well. But you can find that on all of the various channels that you would use: iTunes, Spotify, and
everything.
and on YouTube as well.
I was actually listening to the podcast this morning on my way here, and I what did I say to you? I was like, it's so interesting, so definitely one to watch. Right, next up, Paul's skiving. I hope not. As he visits Halifax Rack and Screw, someone's really engrossed into something in the background as well.
Really interesting feature on this week's Swarf and Chips from me. Simon, you've recently purchased this Multas machine from Alicona to do gear skiving, which has been tremendously successful for you. But the topic of this piece is actually these tools that we've got here. Can you tell us about what you had and what you were using and what you're now going to start using?
The original tooling is solid high-speed tooling that's got an Alicona coating. This tool has got not an extent, it's got quite a limited shelf life. You can only sharpen it 5 times. So from day one we were looking for an indexable carbide tool option. This is the first option that we've managed to find. This is a Seco designed tool.
Now, very, very impressive. Now, what's the operation the tool's actually going to be doing when it's on the machine?
That's going to be cutting a 5DP gear.
Okay, so it's going to be cutting a 5 PD gear. 5 DP gear. This is how you were doing it. Now, for me, to regrind this, you've got to send it away as well.
Yes, we send it away, and it generally takes 3 to 4 weeks to have a sharpen and come back.
And if you can only do that 5 times, then you've got to buy a new one as well.
Buy a new tool.
And where all you need to do now on this solution is change the inserts.
Change the inserts, yeah. And you've got 2. Obviously, it's a two-edge insert.
So when you're looking at the value for this, where do you see, how quickly do you think this, or how much more cost effective is this for you?
This is going to be, according to Seco, we're going to reduce the cycle time by 8 minutes, down to 3 minutes, and we'll be able to run it fast. With it being carbide versus high speed, we'll be able to run it faster, more efficient. Hopefully we'll get a better finish as well.
A great example of a well-engineered solution from Seco. That's it from me here at Halifax Rack and Screw Company Limited.
So this is really quite interesting because you're saving a lot of time, a lot of money. Why hasn't this been brought into the industry sooner? And I know the inserts as well are just perfect.
Yeah, I mean, I'm no cutting tool specialist, but I can see immediately when Simon presented me with these two, I can immediately see the benefits that he's talking about. Seco have obviously done a very good job, and they've captured his attention, and they've developed a product here which is, as he says, going to save him a lot of time.
A lot of money.
You know, he says it all, really, doesn't he?
Yeah, and it's gears as well, isn't it, Gio?
Yeah, I think that there's a higher demand for specialised gears nowadays with the automation industry, automotive industry, sorry, shall I say, the electrification of cars, you know, being able to produce gears complete in one operation on a mill turn such as the Alicona. And due to that demand, they're obviously evolving the cutting tools. I mean, power skiving's been around for about 100 years approximately, but they've never had the technology to produce the gears as accurately as they can.
This is very interesting. There's more videos on the MTD CNC website. In fact, one where I toured the whole factory with Simon. The Alicona was the jewel in the crown of their investment. And I asked him the question because, I mean, you've done more of these than me. The NCMT have held plenty of events. You've been to them as well, where they've been promoting gear skiving. Yeah. I've never been to someone that's actually purchased it and doing it. And I said to him, does it do everything that they say? And he says, yes. The precision of the gears that are coming off, the speed with which he's making them has just revolutionised the company. And it's all to do with NCMT, and you'll know this, the synchronicity, isn't it?
That's the C-axis and the B-axis, the synchronisation, and I think the increments in which the C-axis and the B-axis can synchronise too, I think the increments, I think it's 3.6 million increments, I think that's like 0.1 of I don't know the maths behind it, but it's very, very accurate.
Right. Before we go on to the next machine as well, Paul, he's a big fan of MTD, is that right?
Massive, I mean, we went there to look at actually some Aubamier machines, which now Dugard supply, which they've got 3 of them. And when he contacted us, he was like, come in here, spend the whole day here. We want to do loads of stuff with you. So brilliant guy.
And I know one more thing. Magazine. He was reading it, and you said that was. I said was that stage, and you were like, no.
But I didn't know that he was actually reading it behind. So
there you go.
You say we stage things.
Right. Okay. So after looking at some advancements in machine tools and cutting tools, we now move on to metrology with Alicona.
Well, guys, we all know how important measurement and inspection really is, but I'm here with Brian from Brook at Alicona. We're here at the Coventry University. Now, Brian, when you look at your solutions, your metrology solutions, the optical side, how important is these processes to the industry?
Well, Mark, firstly, we're at the Institute of Manufacturing in Coventry University, which have recently bought one of our systems. The systems that Brook or Alicona make are an optical metrology system. And unlike conventional measurement products such as tactile profilometers or CMMs, they offer the ability to capture 3D data which can then be measured on. So consequently, we're able to measure both surface finish, surface texture, and we're able to measure form, shape, and we're able to produce 3D data which can be exported and used in comparison against things like CAD. So as opposed to conventional metrology, it offers far more. Also, in addition to that, the technology can be easily used in production. So we have systems now which are mounted on the end of a robot, where the robot can be placed over the component to be measured, and that is an inline process. And because of the technology that's used in the optical side of the systems, it is not particularly subjective to either vibration or environmental conditions, so it can be readily used on the shop floor.
And I suppose the advantage, for instance, like Coventry University, it's also about traceability, but also on crucial parts.
Yes, all of the systems we produce have full traceability, and this is an area which is particularly important to people such as Coventry University, where traceability of measurement and understanding of the uncertainty of that measurement is very critical. And again, the optical metrology systems offer that capability.
Thanks, Brian. Well, it just shows you inspection is many forms, but Brook at Alicona is where it's really at.
Wow, fantastic technology. And there is a part of me, I must admit, that thinks, with all of this data, there's so much data, do we need it? And I know it's used for critical parts, but is that then going to critical parts, all of that data, all of that accuracy, going to filter down into other industries? And that's why we need all of this, measurements and all of this data coming back. Because it just
I think it's important to gather data, but there's an argument to say, that some people don't require that level of data, dependent, again, on the industry, what they're making. Is it a critical part? Obviously, for critical parts, it's absolutely essential to have that kind of traceability. And I mean, in regards to the Alicona, Paul, I think that this optical measurement, there's so many different, products now to measure components. I think this stems down to components are becoming a lot more complex, generally speaking, 5-axis machines, 3D parts, better surface finishes are required, tighter tolerances. So these different forms of metrology are coming into play to be able to deal with these different types of components.
It's amazing what it can do.
There was one instance, though, wasn't there, at Reliance that you mentioned we went to, where they had to use the optical measurement because they couldn't use a probe because the part was going into space, and it would have left however minor the
it's a ruby.
indentation.
It's a ruby, isn't it, the probe?
It was,
and that's a hard material.
But it wasn't actually putting a lot of pressure on it, Lindsay. But I can't remember the exact tolerances. It was sometime last year, the beginning of last year. We went to Reliance and met David Tor at Reliance. He had a component that he just couldn't check. Even on checking it on a CMM that's got checking it to point whatever of a micron.
Really?
Because it was a tactile inspection, the actual probe was leaving an indentation in the component. This was a steel component, but because the surface finish and the accuracy was to such, it was phenomenal. So you just couldn't believe it.
When this is the case, though, and critical parts are being made, you know what goes into the measurement of them. Why won't you get on a plane then?
I used to make the parts.
There you go.
I used to make the parts.
You used to make the parts, that's why. Right, finally, you've got the funny man. That is Colin, who visited the home of ABB recently and looks at some really interesting robotics.
We're at ABB Robotics. First of all, we're going to be a bit quiet when we start because they're all learning how to program their robots. They're all concentrating very hard. Look at that for concentration. How are you? There you go. So that's their training school stroke academy. All very impressive stuff. Yeah. And come on. But what we're going to do now is have a look at some of their applications and how they're being used. So here you've got the FP800. Again, you're thinking ABB Robotics, machine tending, robot arms, and this is a test run, practice cell. So there's not a machine, it will sit there when it's done, but there is something unique about this. So doing big castings here. Now, I will make this look like 25 kilos each, so picking them up nice and easy. But they've got the 3D vision system on here. So essentially, robot arm will pick them out of here, out of this pallet, lift them, machine them, then inspect them, then into this pallet, and then put the different layers in there as well. So you've got the green sheet there as a different layer, but that's all in 3D. So that's a unique system from ABB Robotics. Now, come on, Ian, this way. So this is the FP300. What makes this system different is, basically, you get a hopper load of parts. All right, I'm only loading them by hand today, but normally you just sling them in like that. Huge hopper, off and running. You've got the vision system here. It will scan that in 2D. It will then move the part along there, and then, as I said, it's not just about machine tool tending here, the deburring process. So you can see in there, it's picking the part up. Look at that, perfect timing. Over the deburring tool just here. Now, if the audio goes a bit funny, I'm sorry, it's a bit loud, but hey ho, there you go. So deburring. Then blow it off. There you go, and then stack it nice and neatly on the conveyor, all your finished parts. So there you go. That's another different type of application. This from ABB Robotics.
There you go. More varieties of automation. It's interesting to see the different applications that you're going to use it for and the vision system.
This is what I was going to say. The biggest thing to me is the vision element with automation. I mean, you can, how much easier does it make it? You don't have to set the parts in specific areas. The vision does it all for you, but the vision obviously has to be good. Unlike Colin's, he lost his glasses and he fell in a well. He did. And I said to him, "Why'd you fall in the well?" He said, "Well, I couldn't see that well."
Why are we laughing? Don't laugh. Stop laughing at home.
I just like it that Paul loves his own jokes, and it makes me.
We had this discussion the other day, and we know what you do. The shoulders go, and then that's it.
I love this video from Colin. I think what I really liked about it as well, taking the technology aside, is that they were actually teaching people how to program robotics. Now, this is breaking the barriers to entry in regards to people that may have a misconception that it's difficult to introduce a robot into their facility. They can go to that facility and learn, and it's all about education.
And how much has it changed? Because if you think about it now, when I think about my daughter having an iPad, she's 2 and she knows what to do on an iPad. If you're young and you're programming robotics, that is the norm for you. So if you think we're evolving naturally by teaching young people that what is newer to us now, but 17, 18-year-olds being able to program robots.
Absolutely, yeah.
Yeah, but 100%. It's like youngsters these days, they know a phone is a phone, whereas it's not a joke. It used to be mobile. You've got a mobile, but now you've got a phone. A phone used to be what was in your house that you picked up and pressed the numbers, but now a phone kids know phones as phones.
As phones,
you know,
it is crazy. We're all going through this wonderful thing that is life. Anyway, make sure you're listening and subscribing to our podcast that we mentioned earlier on in the show. And on Monday, also tune in to our live question time. And that is the last Monday of every single month as well. Anyway, as we always say, thank you for watching, and thank you, gents, for taking part in this week's Swarf and Chips. What we always say.
Rate the joke. Rate the joke.
Rate the joke. There you go. That could be the cycle time challenge, the rate the joke challenge. Right, anyway, keep those spindles turning.
Keep turning.